Hi students, in this video we are now going to tie a lot of what we've been looking at together into solving polynomial equations. Alright, so after watching this video you should be able to factorize a polynomial using polynomial division by a known factor. And then once you've done that, apply the Null Factor Law to help us solve a factorized polynomial equation. Some things you have to remember: how to carry out polynomial division, or if you prefer, synthetic division, if our leading coefficient of our linear factor is 1. You should also recall our factor theorem. So if if the value of our polynomial at the value of a is 0, then x minus a is a factor, because that value equaling 0 means our remainder is 0. So if p of a equals 0, then x minus a is a factor of p of x. And then something we've done a lot of with our quadratics, applying the Null Factor Law for solving factorized equations. Now, when solving polynomial equations, once they're factorized, we can just apply our Null Factor Law to solve those. So for example, if we've got our polynomial here, it's got our 3 factors, it equals 0. By our Null Factor Law, 2x minus 3 equals 0, or x plus 1 equals 0, or x minus 5 will equal 0. Just rearranging those, x is going to equal 3 over 2, or x is going to equal negative 1, or x is going to equal positive 5. So those values all solve our polynomial. And that's just using Null Factor Law, something we've done a lot of and should be largely familiar. Now, if we've got our polynomial in expanded form, then what we need to do is work towards getting our expanded polynomial factorized. So that's what the first few steps here are. And then that last step is what we just did in the previous example. Once it's factorized, apply our Null Factor Law and solve. Now, with all of it, just like with the quadratic, we want to rearrange our polynomial or our equation so that one side equals 0. Use the factor theorem to help us guess and check our first linear factor. That's using the factor theorem. Use polynomial division or synthetic division, whichever one you prefer, to determine our quotient function, q of x. And then express our polynomial in our factorized form, where x minus a was our divisor from step 2, and q of x was our remaining leftover function, our quotient, we worked out with polynomial division. Then if possible, we should try and make sure we factorize q of x, get it as factorized as possible. And once we've got our equation as factorized as possible, then we can apply our Null Factor Law and solve. Alright, so now let's solve this polynomial equation, applying all of our steps. So our first step is to rearrange our polynomial so that one side equals 0, just like we do for our quadratics. So rearranging that, generally I want my leading term to be positive with the highest degree, the highest power. So I'm just going to move everything from the right hand side over to the left. So that'll be x cubed plus 6x squared minus 9x minus 14 equals 0. And now this is the equation I've got to solve now. Now, looking at our constant term at the back, I can tell that some of the factors I should try using will be factors of 14. So that could be 1, 2, 7, or their negative values, negative 1, negative 2, negative 7. And I can use those to work out our linear factor. Now, just for the sake of time, I'm going to use the one that I know definitely works, which is negative 1. So our second step is finding that linear factor. We should probably start off with 1, sub it in, see if it equals 0. We're not going to here just for the sake of time. So let's say let our a value equal negative 1. So for our polynomial, negative 1 cubed plus 6 times negative 1 squared minus 9 times negative 1 minus 14 equals, now let's see what we've got here, -1 plus 6 plus 9 minus 14 equals 0. So therefore our a value of -1 makes sense. So therefore x minus -1 or x plus 1 is a factor. Now once we've got our linear factor, we can then apply our polynomial division to find out our quotient value, or the leftover part when we divide by our factor. So just writing that out, we've got x cubed plus 6x squared minus 8x minus 14, and we're going to divide that by x plus 1, sorry. Alright, so from there we're looking at x into x cubed, that just goes x squared times, and applying our long division, x squared times x is x cubed, x times 1 is x squared, subtracting those, x cubes cancel, 6x squared minus x squared is 5x squared, bring the next term down, that's not -8, that should be -9, my apologies, minus 9x, once again x into 5x squared, that will just be plus 5x, 5x times x is 5x squared, 5x times 1 is 5x, subtracting those cancel, 9 minus 5x is -14x, bring the -14 down, x into -14x will just be -14, and thankfully there is no remainder as we expected. Alright, so therefore we can rewrite our polynomial here from line 1 as x plus 1 times our quotient function that we just worked out, x squared plus 5x minus 14, and that equals 0. Going back to our first equation here. We've factorized our polynomial by finding our linear factor using the remainder theorem. We got our quotient function by applying polynomial division, and that equals 0. Now our fifth step is working out if we can factorize our quotient here. And just looking at that, we can factorize our quotient. Numbers that times to give -14 and add to give 5. They are going to be x plus 7 and x minus 2. And so we've got our factorized form, and now from here, step 6 is we can just solve that using the null factor law. So by null factor law, I'm just going to skip some working out here. I'm just going to say x can be -1 from this first term, x can be -7 from that second term, or +2 from that last term. And those are all the solutions for our starting equation. If you wanted to check, you could substitute them all in and make sure they all work. I'm confident they do, so I'm not going to. And besides, this video is running longer already. But those are our 6 steps to help us solve our polynomial equation. Right, so after watching this video, you should be able to factorize a polynomial using polynomial division by a known factor, and then apply the null factor law to help us solve our factorized polynomial equation.